Hello and welcome everybody. My name is Wandering Mist and I know it's been a while since I made a tutorial on this channel. Been really busy with other stuff, but this was a topic that I thought was really important, very rarely talked about, and it could save your web app from a security threat. What is the security threat? It is called cross-site scripting attacks. And I'm going to demonstrate what this is. This is something I don't know why, but the majority of full stack tutorials just don't talk about this, and yet it's one of the most common security threats for web apps. It boggles the mind, it really does. Thankfully, there's some very simple measures that we can take to help prevent this. Disclaimer, big disclaimer, there is no such thing as a perfect defense. These steps that I'm going to show you won't protect you from everything, but they will protect you against the most common forms of cross-siting scripting attacks and form a good foundation for further security measures. So if you're looking to be a full stack developer, I would fully recommend watching this through and incorporating these measures into your projects. To follow this video, you need to know the basics of React, how fetch requests work in both vanilla JavaScript and React, and you need to know the basics of an Express.js backend. Let's get started. First of all, what is cross-site scripting? In a nutshell, it's where a hacker inserts JavaScript into your web app, allowing them to do things that they shouldn't be able to. Common world use cases of this include stealing session data from other users, which then allows the hacker to log in as that user without knowing the username and password. They just bypass the whole login system. Could go into more detail, but the ethical hacking community has got lots of videos demonstrating this. One in particular that I like that demonstrates this exactly is Loi Liang Yang. I hope I pronounced that name right. I'm terrible with names, but he has a video on his channel, it will be linked in the video description below, that demonstrates how a hacker can gain access to a login system and log in using cross-site scripting. I'm going to do a very basic version of here just to demonstrate what this is and what's happening. So before I get into the demo itself, I'm just going to go over this project. So I've got this project here. You can see on the left hand side we've got three folders. So I've got my server folder, which is literally just, it's got a server.js file, which is right here. It's your most basic Express backend server. There's nothing really complex to it. You've got a single endpoint which has a post request for it, and literally all this does is it takes in a search parameter from the request body and then returns it as a message. That's it. Very easy. Would you ever do something like this in real life? No, but it demonstrates the point that I'm going to be making. So that's for the Express server. And then I've got two clients. I've got a vanilla client, which is right here, and you can see some of the code here. I'll go into that in a second, and a React client. Okay, so I'm going to show you these preventative measures in both vanilla JavaScript and React. For the vanilla JavaScript, we'll start off with that first because it's relatively simple. Here's my index.html file. You can see very basic. That is on the right hand side, you've got the display of that app. It's got a single text input. It's got a button, and you can't see it at the moment because there's nothing inside it, but there's a paragraph here as well. It's connected to a main.js file, which is right here. And all this does is it sends a post request to the backend server and then gets the result, gets the response from that, and then inserts it into the paragraph. At the moment, it's using inner HTML. Okay, so that's our basic project setup. Just before I show you the cross-site scripting attack, I want to just demonstrate what this whole project does, just so we're all on the same page. I'm going to just put in, let's say Bluetooth in here. There we go. So I'm going to send this. This is our search parameter. This gets sent to the Express.js backend, and then the backend just sends it right back, and then it gets processed, and it goes using inner HTML into the paragraph and then it displays on the bottom. Okay, so anything you put in the search box, click search, it will end up here. Okay, so let's have a look at this cross-site scripting attack and see what happens. So I'm going to put in a new string. This looks really weird. I'm going to explain it in a moment, but look what happens when I press search. Ooh, that shouldn't happen. How did that happen? I've got an alert. JavaScript has been executed. So let's have a look at this string and see what happened. So what I've done is I've created an image tag. Source is equal to X, and then on error is equal to this alert. What is on error? If you've never seen that before, it's a very common trick used by hackers. Basically, the on error is an event that triggers whenever an external resource, such as a file or an image, cannot be fetched. So we've purposely done a source equal to a load of nonsense. There is no X file. There is no image here. So it cannot fetch this image, which means it triggers the on error event, and that then triggers an alert, which is just JavaScript. This could be any JavaScript you like. I'm just doing a simple alert just to demonstrate this, and it triggers that JavaScript. So just by incorporating this and putting it into my search field, I am running JavaScript when I shouldn't be allowed to. That is the cross-site scripting attack in a nutshell. And this is why you will very often get told in beginner tutorials not to use inner HTML, because this is exactly the kind of thing that can happen. So how can we prevent this in vanilla JavaScript? Well, there is a very easy way. If you're only expecting basic strings to come from a input box like we've got here, then we can just change this. Instead of going inner HTML, we can change this to inner text. Okay, so then I'm going to put that same malicious string into here, and now we click search again. Look what happens. Okay, so this is the main difference between inner HTML and inner text. Inner HTML will render anything you put in as an HTML element if it can. So in this case, it would try and render this image tag. Whereas inner text converts this HTML element into just a basic string of text and then displays it on the screen. So we get this. So this is now safe. That's all well and good. So what I'd recommend, fully recommend, is unless you are expecting the user to give you an HTML element to display, use inner text, and then you're safe from this kind of attack. But let's say that for whatever reason you do expect an HTML element from the user and you want to be able to display it properly. So how can we do this while staying safe from these kinds of attacks? Well, there's a lovely package that we call DOM Purifier. Link will be down in the video description, but what it does is it purifies the DOM. So I'm going to show you exactly how to do it. Now, if you're wondering about these extra files in here, I actually created this vanilla client using Vite, which means that I have access to NPM and I can install all NPM packages into this project. So if we have a look at the package.json file, you can see there's DOM Purify right here that I've already installed. All I have to do now is import it into my project. So what I'm going to do, up in the top here, I'm going to just import DOM Purify. Helps if I spell it right. DOM Purify from DOM Purify. There we go. And now to use it, there's a method we call sanitize. Okay, sanitizing is just it's going to strip out a whole bunch of stuff that is deemed malicious and just clean everything up. I'll show you exactly what that does in just a moment. So I'm going to come down here, I'm going to create a new variable called clean. So we've got dirty and clean. Clean, and we're going to equal that to DOM Purify.sanitize, and then we're going to pass in our result.message. Okay, so now if I change this, I'm going to change this back to inner HTML, and I'm going to set this to clean variable. We're going to save, and now let's pass in this malicious string again and see what happens. Okay, well, that's all. That's great. Got no pop-up from the code that I inserted, and it's trying to display this image. Of course, there's still no image, so it can't display anything, but at least it's not executing the JavaScript. So what's happened here? Let's take a little look. I'm going to just inspect this image element. So here's our paragraph that we inserted the image into. If I look under it, we've got just image source equals X. So DOM Purify has seen, oh, there's this on error and this JavaScript inside this image tag. I'm going to strip that out and just leave the basic image with the source. That's it. And that's what we get. And that, again, so this is how we can protect ourselves from these kinds of attacks while still being able to display HTML elements that the user has submitted to us. Of course, again, the majority of cases, you're not going to be expecting HTML elements from the user. So inner text is probably the best way to go with that. But this is an option if you do need to have HTML elements displayed. Moving on then, we have the React. So let's switch over to our React client, and I'm just going to show what I've got in the React client here. Okay, now again, very, very similar. Literally all I've got here, I've got this simple app component. It's got two pieces of state. We've got our search value, which is linked to our input here. And then we've got power value, which is the value that's going to be displayed. This is what gets sent back from the server, and then it's displayed inside the power here. React is great for security because it does a lot of the things for us. So that whole issue we had with the vanilla JS, with it trying to render that image element, React takes steps against that. It's got base level of protection for us. So I'm going to use that same malicious string that I did before. I'm going to post that in here and take a look. Okay, so again, it converts it to a plain text string and just shows it on the page, and that's it. So again, we are protected from this kind of thing. But again, the issue is, what if we want to display HTML elements on the screen from a user input? What do we do then? Well, React has given us a way of doing that, aptly named dangerously set inner HTML. I'm going to show you exactly what that does. So underneath the paragraph here, I'm going to create a new element. I'm just going to copy and paste this in, and we're going to set this to the power value. Okay, so I've just got a simple div element, and then I'm using this dangerously set inner HTML. This is just a prop, and it passes in an object which contains the value that we're passing in. Okay, so let's do a save. Ooh, immediately I didn't even need to send the fetch request. Let's do a refresh on that and do the string from the top. So again, here, click search, and we get this alert, same as before. So the cross-site scripting attack has gone through because I'm using this dangerously set inner HTML. So what this does is it disables that baseline of protection the React usually gives us and renders the HTML element as it was given to us. So how do we fix this? Because this is no good. We can't have this. We fix this by, again, DOM Purify to the rescue. Let's import it and see what we can do about this, okay? So I'm going to just copy and paste in some code, and then I'll explain what it does. What I've got here, I've imported DOM Purify. Again, this is already pre-installed. I've got it in my, this is in my React package.json file, and there is DOM Purify, so I've already installed it. And I just import it into the file, sanitized, I've created this new piece of state called sanitized. And then inside my search function, I'm going to set sanitized to DOM_purify.sanitize, and we're going to pass in the message like that. Okay, we're going to click save. And now let's see what this does. I'm going to pass in my malicious string into the search box. Click search. And just like before, DOM Purify has come along and it has stripped out the malicious JavaScript code from our image element. Now, you may be wondering, okay, fantastic, that's it, we're done. We're not. Unfortunately, there are many different kinds of cross-site scripting attacks, and I'm going to demonstrate a different one right now. Very common one, actually, which is it abuses the attributes in things like an anchor tag. So I'm going to come down here, and I'm going to just copy and paste in this. Take out this. So here I've got an A tag, and I've labeled this bad link to a website. In here, I'm going to pass in the power value. Okay, so now I've got my bad link to a website is right there, and then I'm going to pass in this second string right here, which is just JavaScript alert hello. We're going to post that in there and click search. Okay, so it appears we're okay. Nothing bad has happened. No pop-up. Look what happens when I click the link though. Oh dear. That is not what we want. This is really malicious. Like, this is so dirty. Because your average user isn't going to inspect a element to check where this link goes to. They're just going to look at the text that is displayed. Like, I could change this to, let's just change it to Google. If I change this to google.com, yeah, your average user is going to look at that and say, oh, that takes me to Google. Click. Now, obviously, this is really obvious what it is, but again, this can run any JavaScript a hacker wants, which means it can be used to direct the user to any website they like. And it can run any JavaScript they like. Okay, again, we don't want this. This is bad. So, what can we do? This is where the server-side sanitation and protection comes in. So I'm going to hop over to my server.js file, and we're going to have a look here. We need some protection. The key thing in this malicious string is this JavaScript colon right here. So what we want to do is to convert this into something that is safe. So I'm just going to copy and paste this code in, and then I'll tell you what it does. We've already got this search parameter coming from the body of the request. Then I'm doing a if statement. So I'm saying if the search includes, so I'm using the .includes string method, if it includes JavaScript colon, then I'm going to replace that. I'm going to replace that with JavaScript colon void 0. This is just a void function. It basically says JavaScript, do nothing. Essentially. Kind of useless, but it gives us some level of protection. So I'm going to save this file and then come back to our React, and let's try that request once again. I'm going to refresh this page. I'm going to come in here, click search. Okay. Now, if I click on this, nothing happens. And that's because we have changed the href to this JavaScript void, and void just means do nothing. Yeah. After that, anything that comes after that isn't run because we've already voided everything. We've stopped the function. So this is a nice little thing that you can do. And you can either do this on the server or you can do it in the client. I prefer to do this on the server. The more stuff that you can do on the server, the less work the client has to do. And this is important, especially if you don't know who the clients are. If you're designing an API or writing an API or doing a server for somebody else, somebody that's not you, and maybe they're not as security savvy as you are, then it's important to have these level of protections on the server side as well. So with that in mind, I want to add in some more server-side protection. And what we're going to do is we're going to use a package called Validator. Validator, it's a very simple package. Again, link in the description below. It offers us a whole range of different functions that help us validate user inputs, so check that the inputs are what we believe they should be, and also sanitizes them, making them safe to use. I'll show you what this does. So up in our server.js file, we're going to import validator from validator. And then inside our post request function, we're going to use that. So I'm going to say search equals validator dot escape. Oops. And then this passes in whatever string we want. So we want to do the search and then dot trim. Okay. So what does this do? One of the most common things of protecting against malicious scripts and HTML elements is to change certain special characters into HTML entities. I'll show you what that means in just a moment. So that's known as escaping. So in fact, if you hover over, you can see here, it says it's replacing the angle brackets that are commonly used in HTML tags, as well as some other things, with HTML entities. And that's just a little code that links to the symbol. So we're replacing everything in the search parameter with these symbols, and then trim just removes the white space from the beginning and end of the string, just to clean it up a little bit. Okay, so I'm going to click save on that file, and then I'm going to come back in here, and let's change this, the power value right here. And just to showcase what these HTML entities actually do, I'm going to do this. So I'm going to say Harry and James. So this ampersand in the middle here is a special character that is replaced when we do the escape function. So I'm going to click search, and you can see here, this right here is our HTML element. So that doesn't look great. We want to see the actual ampersand. So how do we fix that? Again, we can use the validator package on the client this time. So I'm going to go import validator from validator. And then down here, the set power value, I'm going to call the validator.unescape method this time, and then pass in message. Okay. So let's try this Harry and James string once again. And there we get Harry and James. And everything is protected. So what we've done here is very simple. Let's be honest. We're talking about half a dozen lines of code here. Not a lot. And yet we have protected ourselves against the most common forms of cross-site scripting attacks. There's one more thing that I want to just talk about briefly, and that's Markdown. So very common these days to use a Markdown editor where the user can input some stuff and it changes it and renders it into HTML elements. If you've never seen Markdown before, don't worry, I'm going to go through it real quick. So for this, I'm going to import a Markdown editor package. So right here, this is our Markdown editor. And then I'm just going to display it on the screen. We're going to come down here and we're going to display this on the screen here. So all this does is it's displaying some Markdown for us. It's got this source, which is the MD string. I'm going to add that in. I'm going to just do it in the main body here, just for demonstration purposes. So again, if you've never seen Markdown before, this looks really weird. What this is doing is it's creating an image on error alert. So we're going to click save on that. We're going to refresh. There is auto there. And let's have a look and see what we're doing with this. So the markdown has, oh, look at that. It has changed the different things. It's basically done what the validator escape method has done. It's changed some of these things into HTML entities, which then makes it safe. This code, because of all these entities, it cannot run the normal JavaScript. So it's converted it in and it's kept it safe. So this is a built-in function to this markdown editor. My advice to you is, if you are using a third-party markdown editor, make sure that they have this kind of protection in before you use it. Okay, very, very important. Make sure they've got this kind of functionality where it makes these kinds of malicious strings safe to be displayed on the screen. So that's about it. I hope that's been useful for you. If you have any questions, put them in the comment box below and I'll do my best to answer them. And yeah, let's make all of our web apps a little bit safer than they already were. Thanks very much. Goodbye.